Students, we are going to do experiment number 3 of ROBO 124, universal property of NAND gate. The first circuit we are going to mount on the breadboard is this. The same idea as you were doing last few experiments. There are two switches and you are going to give plus 5 volts here, and in here you are only going to use NAND gate and you are going to make it work like NOT gate. So pin numbers 1 and 2 are short circuited. Pin number 3 is connected to pin number 1 of 7404 IC. Pin number 2 is connected to the negative of the LED. Positive of the LED through this 330 ohms is connected to plus 5 volts. Now when you keep the switch open, you are applying a 1 to this input. The same one goes here. So A is the input. When it comes out of this NAND gate, it is going to become A bar. So if you give a 1, you're going to get a 0. So if the switch is open, the LED is going to light up. If the switch is closed, the LED is going to be off. This is the circuit. Remember to connect pin number 14 to VCC and 7 to ground always. Here 14 to VCC, 7 to ground. Okay, I have used switches 1 and 4, but for this NAND gate as not, we only need one switch. So from switch 1 I have connected to NAND gate pin number 1. 1 and 2 are short circuited. Pin number 3 is the output. That goes to pin number 1 of the NOT gate, and pin number 2 gets the cathode of the LED, and anode of the LED goes through 330 ohms to positive of the power supply. This I have connected to plus 5 volts, and this is connected to ground of the DC power supply. The switch is closed, so I am applying a 0. The LED is on, producing a 1. Now let us open the switch. The LED is off, producing a 0. I apply a 1, I get a 0. Now that you finished circuit 1, you record the readings in table 1. Switch close is like applying a 0, LED is on, like producing a 1. Switch open is like giving a 1 input or a high input. The LED is going to be off, so you are producing a 0 at the output. This is the second circuit you are going to mount, hook up on the breadboard. The NAND gates are connected such that it produces an output of an AND gate, A dot B output. Pin number 1 is connected to switch 1. Pin number 2 of 7400 is connected to switch 4. Now pin number 3 is connected to pin number 4 of 7400. 4 and 5 are short circuited. The output pin 6 is going to produce A dot B. This is a shorted NAND gate working like a NOT gate. So here what you get is A dot B bar, and when it comes out of this shorted NAND, you get A dot B double bar, where the double bar gets cancelled and you have the output A dot B. So now when you keep the switch 1 and 4 open, the LED is going to glow and the LED is going to be off otherwise. If any of the switches are closed, you are going to get a 0 at the output. The circuit is here. Now I am going to use these switches 1 and 4 to produce the output. Now both the switches are closed, like giving a 0 and 0, 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. Now that you have finished circuit 2, you are going to record the values in this table. It is AND output, so 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. So when switches are open, you are applying 1 and 1 to the inputs and you are producing a high at the output. Now we are going to do the circuit 3, which is going to produce the OR output A plus B. Note the pin numbers, connect as per the pin numbers. Never forget to connect pin number 14 to VCC, 7 to ground. This is the third circuit we have mounted. Now 0, 0, 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is also 1. We are going to hook up circuit 4. This is going to produce an XOR output. Again, note the pin numbers, pin number 14 to VCC, 7 to ground. Now, how we would obtain the expression for the XOR gate, I have shown on the other side. Here is the output Z. Now I applied De Morgan's law and I arrived at AB bar plus A bar B, which is A XOR B for the Z output. Now we have hooked up the circuit here. Any difference in input should cause the LED to glow. So now this is 0 0, LED is off, 0 1, the LED is on, 1 0, the LED is on, 1 1, the LED is off. From the third circuit, whatever output I got, I have noted here. These are the output from circuit 4, I have noted here. Part 2 is IC minimization. You are going to draw a logic circuit for this expression, and you are going to try to make the logic diagram just with NAND gates, and then you are going to see the output and record the values. You are not going to build the circuit. You are going to answer these questions and you are going to submit the report. Thanks for watching.